Very good. Welcome, everybody. So today we're going to talk about the graph and the level curves of multivariable functions. Let me make sure you can see the board. Graphs of multivariable functions. Well, so far we learned that we can, let me just change the audio. Yes, that's good. We learned that, well, we can use some nice and cool free websites to graph, for example, two variable function, like z equals to f of x and y. Remember that we have two free variables, like x and y, and we can freely, not exactly freely, that depends on the definition of the function. We can choose x and y, and z depends on the choice of x and y. Then we can graph these. We can graph the domain, and also we learned that we can graph the function z as well. So far we talked about these two. Another method that helps us to visualize and understand the behavior of these types of functions is using the level curves. So let's talk about the level curves for these types of functions. The level curves. Well, if we have a three-dimensional object as z equals to f of x and y, the visualization can be something like this. You can visualize this function in the space as, for example, here you have your x-axis, here you have your y-axis, and here you have your z-axis. Well, this object is going to behave, for example, like this. Some mountain, for example, in this space. This is z equals to f of x and y. Well, from elementary calculus, remember that you learned about curves in two-dimensional plane. We know that if we have z equals to a constant like k, so k is a constant, these represent some planes parallel to x, y plane, right? Are some planes parallel to xy plane. This is what we learned before. So when we're talking about level curves, these are curves in two-dimensional space. What are we going to do? We're going to take different planes and slice this surface with those planes. Okay, what do you mean by that? Take a look at this. Here I'm taking this plane. Z equals to, for example, 1. I look at the slice of intersection between z equals to 1 and this three-dimensional object, this surface, whatever it is. There is an intersection here. This intersection is some curves in 2D. Wow, okay. Why don't you use another plane like z equals to, for example, 2? Why not? We can take as many planes as we want and slice that with this object, this three-dimensional object, and get some level curves. So these are called level curves. So this is the idea behind the level curves. But how do we actually get those level curves? To find the level curves of z equals to f of x and y, we set f of x and y equals to the constant k. Then we try to, for example, write y in terms of x in terms of y, or writing a relation using x and y. Then we try to determine this relation. Well, it might be some lines or some parabolas. It might be some, for example, circles, and many more things that you learn from algebra. These are all algebraic. Conic sections, what you learned, conic sections. What you learned about the algebraic relation between x and y and the graph that you can derive from those.